Okay, so we're going to talk about rational, which is another word for fractional, exponents. We have an example. We have the square root of 25 is equal to 5 because we know 5 squared is equal to 25. So if we square 5, we get 25 in return. And so the square root of 25 squared is equal to 5 squared, which is equal to 25. Okay? So it appears that squaring a square root cancels it out. So we're going to look at the powers because of that. So could we rewrite the square root of 25 as 25 to some power? And the answer is, if we thought of it like this, we would have the square root of 25 squared, obviously in parentheses. What power would we be raising it to? Well, we know that the power rules work, that if you raise a power to power, you multiply the powers. So what we end up having is 25 to some power to the second power is equal to 25 to the first. Well, if the exponents are able to be fractionals, or fraction, we still follow the same properties of exponents, and then we have the square root of 25 is 25 to the 1/2 power. And note that 1/2 times 2 is 1, so that's why it's 25 to the 1 in that case. Okay. Similarly, if you have the third root of 25, you have 25 to the 1/3 power. 25 to the the fourth root of 25 is 25 to the 1/4, and 25, the fifth root of 25 is 25 to the 1/5 power. Okay, so we are now able to change radicals into a different form using rational exponents. So it's just another way to write a radical. So in general, the nth root of x is equal to x to the 1 over n. Okay, simplify the following. We have the fourth root of 81 and the fourth root of 12, x to the 12th. So we have the fourth root of 81 to x to the 12th. We know that if we did that on the last one, outcome must be positive since the index is even. We know the fourth root of 81 is 3 because 3 times 3 times 3 times 3 is 81. That's 4 of them. And then we have x to the 12th to the 1/4. Well, 12 times 1/4 is 3. And so we know that we need the absolute value in this case because we need x to the third to be positive. Otherwise, this won't work to begin with. Okay. So in general, x to the n to the 1 n over n is equal to the nth root of x to the n, which is equal to x if n is odd. And then the absolute value of x if n is even, that's just because we need it to be positive in that outcome. Okay, so that's the thinking behind this. So with that being said, we can extend the definition of x to the 1 over n to include fractional powers with numerators other than 1. Simplify 8 to the 2/3 power. So 8 to the 2/3 is equal to 8 to the 1/3 to the second power, which we know the third root of 8 to the second power. And so that's the third root of 8 is 2, because 2 times 2 times 2 is 8, and 2 squared is 4. So your answer here would be 4. Or you could do it the other way. 8 squared is 64. The third root of 64 is 4 times 4 times 4, so that is also 4. If m and n represent positive integers and n is not equal to 0, then x to the mn is equal to, obviously the denominator is the root, the power is the m, or we have the x to the mn, and then you can raise it to a power on the outside. Either way it works. The denominator becomes the index of the root, obviously. Okay. A to the n normally means multiply a by itself n times, but do not mistake it with the sense to multiply a by itself a fraction number of times. So what exactly does a fractional exponent indicate? 32 to the 0 is 1. We know that. 32 to the 1 is 32. 32 to the 1/5 is 2, because if you do 2 times 2 5 times, you'll get 32. 32 to the 2/5 power. You can see that's 2 squared. That's 4. Next one. 2 to the 3rd, that's 8. 2 to the 4th, that's 16, and then 32. So there's kind of a pattern emerging. Okay. Finally, simplify the negative 64 to the 2/3 power. So the third root of negative 64, that has a real root because if it's an odd index, We know negative times negative is positive, times negative is negative again, and so 3 negatives make a negative, so third roots and fifth roots and things like that exist if the index is odd. So the third root of 64 is negative 4. Negative 4 squared is 16. Simplify 36x to the 6th. Okay, so if you wanted to do it, the square root of 36 is going to equal 6. The square root of x to the third, 6th is x to the third. And then cube those things, and so we have 6 to the third, which I think is 216, and x to the 9th. Okay, simplify the next one. This is 1 over, we got the negative, I'm sorry, we have the fraction here because that's a negative 3/4. Okay, there's one issue though. We have the fourth root of a negative number. Obviously, that is not good, and we cannot do this. Actually, oh, wait. Sorry, the negative is multiplying this thing. Sorry, we can still do this. So we would do the fourth root first, and then the negative stays on the outside, okay? So, there it is. So we pull the negative out. Now we can do it. Sorry, I totally forgot. I was looking at it. Okay, so the fourth root of 625 is 5 to the third, which is negative 1 over 25. Everybody, I hope you understand that negative here means multiply by negative 1. We have to do order of operations, would say do exponents first. So by flipping it over and doing the fourth root and the third power, we are doing that, so we are safe to do that, and that is why that has a solution. Next, we have the ninth root of 27, ninth root of 6, and the ninth root of y to the third. It's kind of gross. That's 3 to the third. So all we're going to do is we're going to change these to a little bit nicer. That's 3 to the 1/2, 3 to the 2/3, y to the 1/3. So if we wanted to simplify it, we could leave it like this. And then finally, we can distribute these and multiply. And when we multiply, we add the powers. So we're going to get 6 to the third and 3 to the third, which is x squared plus x to the 1. And so that is your solution to that one. I hope this helps. I hope you guys can go through this and understand where these are coming from. Obviously, there are more help videos online if you need to find them. Don't forget to ask if you need help, and I can help you. Thank you, guys.